Hi, so in this video, we're going to look at forces and acceleration. In particular, we're going to apply Newton's second law. And this states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. So the resultant force, F, is the product of the mass and the acceleration. And this is true for weight, where m is still the mass, but g is now the acceleration due to gravity. And this is approximately 9.8 meters per second squared. So we're going to apply these ideas in example 1, where we've been asked to work out the magnitude of the unknown forces P and Q. So in question 1, we've been told that the particle of the object is moving to the right, and it's accelerating to the right by 4 meters per second squared. So because we're only told it's moving to the right, it will have no vertical acceleration, which means the Q and the weight must cancel each other out. So this means that Q must be equal to the weight. So we can say that Q is equal to 3G. And to work out P, because it's moving to the right, this force P must be greater than the force acting in the opposite direction, which is 2. So there will be a net force where P minus 2 will give us a resultant force. And the resultant force will have a product of mass and the acceleration. And we've been told that the mass is 3 kilograms and the acceleration is 4 meters per second squared, so 3 times 4. So P will equal 12 plus 2, P will equal 14 newtons. Okay? So do you want to try these same ideas to try and work out Q and P in the next question? You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So we told that it's accelerating upwards, which means that the two horizontal forces must cancel each other out. So the force pulling it to the right, P, will be the same as the force pulling it to the left, which is why there's no horizontal change. So P will equal 2 newtons. To work out Q, because it's moving upwards or accelerating upwards, we know the force Q must be bigger than the weight. So the net force will be Q minus 5G. Again, this will be the product of a mass and the acceleration. So Q minus 5G will be the mass of 5 times the acceleration of 5. So this will give us 25 newtons. And next, we can move this negative 5G to the right side. So Q will be 25 plus 5G newtons, which works out as 74 newtons. Okay? Let's move on to question 2. In question 2, we're told that the engine of a car has a mass 1,200 kilograms and can produce a driving force of 2,000 newtons. And we've been told to ignore any resistance forces. So we've been asked to calculate the car's acceleration and the time taken to travel 27 meters per second from rest. So the first thing we'll do is we'll draw a quick sketch. And because we can ignore any resistance forces, we can say the force of the car will be the mass multiplied by its acceleration. So the force will be equal to the mass multiplied by the acceleration. So the acceleration will be 2,000 divided by 1,200. And this gives us approximately 1.67 meters per second squared. So for part B, well, we know because it's going from rest, the initial velocity is 0. We know the final velocity is 27. We want to work out the time, and we've just worked out the acceleration as 1.67. So the formula connecting these four is V equals U plus AT. So we'll substitute in for 27 for v. U is 0, a is 1.67, and t is what we're trying to find. So we can say that t will be 27 divided by 1.67. And this comes out as approximately 16.2 seconds. Okay, let's try one more question. In example 3, we're told that an object is pulled from rest along a horizontal surface by an inextensible string. So the inextensible bit means that the string does not stretch or compress. The tension in the string is 70 newtons, resistance force is 50 newtons, and the normal reaction force is 49 newtons. And we've been asked for part A to work out the mass of the object. So if you want to try this question yourself, you can pause the video, and when you come back, we'll go through the work solution. So welcome back if you're ready to go. So I've drawn a quick sketch where we have the surface here and the object lying on the surface with the inextensible string having a tension of 70 newtons, the resistance force having 50 newtons in the opposite direction, and the normal reaction of 49. So to work out the mass, we know this is acting downwards as weight, and this is mg. And because there's no vertical change, the weight must be equal to the normal reaction. So mg must equal 49 newtons. We know g is 9.8 meters per second squared, so m will be 49 divided by 9.8, which gives us 5 kilograms. We know the force to the right is bigger than the resistance force, so the resultant force will be 70 newtons minus 50 newtons. So this 20 newtons is made up of the product of mass and the acceleration. And we've just worked out the mass as 5 kilograms. So 20 will equal 5a. So a must be equal to 4 meters per second squared. And that would be the acceleration. And finally, for part C, the velocity of an object after 5 seconds. So we're told it starts from rest, which means u equals 0. V equals what we're trying to find. T we're given as 5, and the acceleration we've just worked out as 4. So again, we can use V equals u plus at. So V will equal 0 plus 5 lots of 4. So our final velocity after 5 seconds will be 20 meters per second. Okay, so thank you very much for watching, and I hope you found that useful. You can download a full lesson and worksheet from my website, mrmathematics.com. You'll find a link in the description below. Thanks again, and take care.